So in this very introductory session, we're going to take a quick look at Maya. We're going to have a bit of a run through the layout of the program, and we're going to start modeling using polygon primitives. So I'm on a Mac, so the user interface might be ever so slightly different if you're on a Windows, but it's also going to be different if you're on a different version of Maya. So I'm on Maya 2017, but Maya 2018 is available, so it might be that you have that version, in which case some of the icons might have changed, the general layout might have changed. If you're on an earlier version of 2017, certainly 2015 has an extremely different visual look to it. But generally all the tools within Maya are the same, it's just the way that they look. But hopefully we should be able to find our way through the program anyway. So on a Mac, you'll go into your applications folder, and you'll then find the folder for Maya. Let's just close that. So in Autodesk, you'll then have your folder for Maya, and mine's 2017. And then I'll double click Maya. You'll get a splash page whilst it's loading. And it might ask you about licenses when you first sign in if you're setting up a student license. Usually what you'll also get is a what's new feature. So this is going to highlight all the new stuff that's in the program since the last version. So for me, anything that's highlighted in green with these brackets here is going to show me the new stuff that is just in as standard. You can tell it not to show that, but we'll keep it on because we're not going to look at any of the new stuff until much later on. So we'll keep it on for now. So this is how Maya loads up for me. It's loading up in the perspective view. So you can see down the bottom here in the center, it titles the view that I'm in. And so perspective is basically telling us that this is a 3D view that we can orbit around, we can move around, we can zoom in and out of, and we can see any geometry that we create in perspective. So just to run through the main parts of the user interface. So up at the very top here, we have our menu system. Now on a Windows, what you'll probably find is that the menu system is actually directly on the top bar rather than in this kind of windowed mode. That's just a bit of a UI difference between how Mac and PC programs are laid out. But everything that's in here should basically be the same. So we'll be using some of these to find certain tools, and we'll kind of go into here and then find that some of them have kind of sub-menus. Any ones that have a kind of square on here have settings that you can change for that tool before even invoking the tool. So we'll be looking at all of that. It's a very complex system. One downside of Maya is that they've been upgrading it consistently for 20-something years, which is very good, but they never throw anything out. So pretty much you will find the same tools in here that were in the first version of Maya, and you will find every tool that has been introduced since is all in here. And what that does mean is that if we look at the menus, they are absolutely jam-packed full of all sorts of stuff, to the point where it's actually mind-boggling if you've never opened a 3D program, because there's just so much options. It's kind of option paralysis. We'll be looking at a very small section of these tools to start with, and you'll begin kind of working with them as you progress further into 3D animation or 3D modeling. So that's our menu system at the top. We've then also got some we've got a shelf here that we can change. So there's a drop down, so we can go into our kind of modeling view, rigging, animation, FX, rendering, or a custom view. And so all the tools are available in the program in any view that you're actually kind of in. It's just whether or not you're going to have the quickest of access to them. So you'll see that if I'm in modeling, which I am at the moment, I've got things like curves, polygons, sculpting, rigging, all this sort of stuff that I might need to use is kind of here at my fingertips. If I change to rendering, for example, we have a different layout of what's on the top here. And as we kind of go through some of these, we'll find that some of the icons are missing based on what they've set up as these kind of workspaces. You also, on the right hand side, you have this kind of secondary workspace section. So you have a Maya Classic, Modeling Standard, Expert, Sculpting, and these again will change the layout of the whole program to give you more space for certain tasks, or to give you access to certain windows that you're going to require for parts of your workflow. But we're going to work on the Maya Classic, and we're going to work modeling just to keep everything as kind of basic as possible. Generally speaking, that should be how it loads up straight out of the box anyway. So onto our shelf then. So this is the shelf within Maya, and so you have a shelf for each different type of thing within it. So we have curves and surfaces, polygons, sculpting, rigging, animation, etc. For today's purposes, we're only going to be looking at the polygons one, and we'll be able to kind of make some polygons, talk about them a little bit, and then start working on an actual project ourselves. The other things that you'll need to know then about this program, on the left hand side you've got a bit of a toolbar. So some commonly used tools are here. So you've got movement tools, rotation tools, and scaling tools. We also have selection tools at the top. We've also got a set of buttons which allow us to change the types of views that we're in. So at the moment we're in a one panel view, so we can see one version of a model that we have. But we can change that to a 4-panel view, where we'll have our perspective view up in the right hand corner, our top down view, our front view, and our side view here. We can also do a side by side, or we can actually just have our outliner, which is it's similar to a layers system that you'd have like in Photoshop, but it's a bit more involved in that. It keeps all your groups together. It's where anything that's used to create any geometry is all housed in here, and effectively anything that is within your scene can be found within the many trees that get populated in here. So it's a way of being able to kind of select stuff that isn't visible at the moment. So we'll touch on that much later though. I'm going to turn the outliner off, and I'm going to go back into our perspective view to start with. So the first thing we're going to do is we're just going to make some polygon primitives. So a primitive is a form that is created by the program in 3D that it can figure out how it needs to be placed in the scene in a mathematical way. So what I mean by that is that it's hard coded into the actual program to understand what a cube is, for example. So if we click on the cube here, it will then populate a cube into the center here. In other versions of Maya, you might need to click on the cube, and that opens it as a tool, and then you bring your cursor down here, and then you kind of click and drag to create the dimensions of the cube. In 2017, it just populates one that we can then change afterwards. So Maya understands what this is. It's in that it's a cube. It can do things mathematically to this without having to understand anything complex about its geometry. So what I mean by that is that at the moment it's set it up so that it's a 6-sided shape. It doesn't have any information within these 6 sides. Just by the way, I am holding down Alt on a Mac, and I'm then able to click and drag to orbit around my scene. I can also scroll in and out with the scroll wheel or the trackpad on a Mac. But so there's no extra information here. It's a side and a side and a side. Now, if you look at the icon of the cube up in the shelf, you can actually see that they've cut these sides into 4 separate panels anyway. So that's a further subdivided cube. Now, Maya can understand anything that we tell it to do with a cube if we're not massively deforming it. If we're just telling it to subdivide it into extra sections, it can mathematically understand that without having to do anything complex. So that's what a primitive is. So to show that in action, what I'll do is I'll start subdividing this cube for how we might want to be playing around with it. So if I've got my cube selected, so selection tool, got the cube selected, and it's got a green outline, tells me that it's selected. And I've got on the right hand side here, I've got a few options that I can play around with. I've got my channel box and layer editor, my modeling toolkit, and my attribute editor. So we probably won't be looking at the attribute editor for a little while, but we will be switching between the channel box and the modeling toolkit. The modeling toolkit is just a really quick way to find really useful tools that we're going to use a lot. And the channel box gives us basically the properties of the object that we've got selected. So the object I've got selected is p-cube1, and it gives me its information based on its 3D positioning. So it's in 0, 0, 0 across its translate and rotate. That means that it's basically not been moved in any way. So if I were to say translate this to 3 and hit enter, it's going to move our cube from the absolute center here over to 3. And that actually works in a grid system. So you see that the absolute center of where this square is originating from is on the 3rd line within our grid. So it was at 0, and then if we had moved it 1, it would move to 1, then to 2, and then to 3. And that's moved it in the x-axis. So that was moving it +3. So if we were to move that to -3, it will be offset on the other side. So again, if we find our center point, 0, -1, -2, -3, we can put it back to 0, and it's obviously going to be centered. Our y-axis is our up and down, so we can translate that, and we could say, well, let's put that to, we'll put it to 2. And so now that's going to be kind of up in the sky a little bit, if we imagine this grid as being our floor. Equally, if we put that to -2, it's now going to be underneath our floor, so we can, you know, kind of be on top of it, even though we're on the floor level. We'll put that back to 0. And our z-axis, our z-axis, is how far we are pushed back into the background, or how far forward we're coming from the background. So if I were to put this to 3, it will come towards us. So it's now moved that way. And if I now move that to -3, you'll see it goes further into the background. That's just very basically how the program sees things in 3D space. It's all about kind of how it is relative to the origin point of the scene, and the origin point is this crosshair here in 3D space. So nice and simple. We then have our rotate. So our rotation, again, it's got no degrees of rotation in any of the axes. But again, if I were to type any of these in, so let's say I put 20% in the x-axis, you're going to see that if I now rotate around this, we've actually tilted it slightly. So I'll set that back to 0. If I did it in the z-axis, again, you get the same thing, that it's tilted it, but moving the other way now. And then in the y-axis, it's going to spin it in place. So if I put 20 on there, we'll have to go over the top of it to see that actually we've kind of turned it as if it was on a turntable. So then we come down to our scaling. So these ones by default are at 1 rather than at 0. And so what this is saying is that based on the standard Maya units, which is, it's kind of arbitrary, but it gives it something to work to, where it can compare one form in its scale to another form. But basically it's saying, well, it's a scale of 1. If we were to scale that to 2, it's going to get twice as big. So if we scale the x-axis by 2, you'll see that we're now twice as wide, but we haven't changed in the other directions. We could then obviously update all of them, and then we're going to have a square that's twice as large in each direction. But equally, we can go down into smaller sizes. So we can go to, say, let's 0.5. So it's going to be half the size of the original form that it came out with. And so that's going to give us 0.5. And of course, we can decide to do this uniformly between all of the axes, or we can just do them for whatever we need. So what happens if we try and put in a negative number? So we started with 1. So what's going to happen if we start to play around with negative? Well, nothing really. It's not going to compute anything different, because effectively it's just reading its numbers backwards. So because it's a mirrored object, it's not really going to be an issue. But this is going to be something that we're going to be able to use once we've created a shape. If we want to make a copy of it and have it flipped on the other side, let's say it's an asymmetrical shape that, in fact, I'll very quickly make something like that. So if I go back to this being 1, 1, and 1, I'm very quickly just going to use some tools. We'll go over these in a minute anyway, but I'm just going to use some tools to kind of build something out of them. I'm going to use the extrude tool. So I'm going to select a face, and I'm going to select this face. I'm going to do extrude and do that there. I'm select this face, do extrude and do that there, and then this face and extrude and do that there. So we've almost got like one of those Tetris pieces, although obviously I've not been particularly tidy with getting it exact. But so now we have a shape that isn't symmetrical. So, you know, if we wanted to have an exact copy of this object but rotated, then we could kind of select it. We could hit Command D on a Mac to duplicate. I think it would be Control D on a PC to duplicate. Or if you're wanting to do it by the actual process, you would go to File. See, I never use the menus for everything. I use keyboard shortcuts. Edit down to duplicate. There we go. And you could then go and just press it in there, or you can do the keyboard shortcut that's there. So that would then give us a shape. So let's do that again. So we'll select our shape. We'll go to Edit, Duplicate. So I now have two copies of the shape, but they are stacked on top of each other, so we can't see them. Now I can move these with our translate tools if I wanted to. So I could say, well, I want to move the x-axis of this to -5 now, and that should bump it left by a fair margin, which separates them out. I'm going to undo that, so I'm hitting Command Z. It'd be Control Z on a PC. So I could do it like that, and I could actually put the inputs in there, and that's actually really useful if you are modeling something that has very high tolerances. It's good to know the exact numbers that you're using, rather than just doing it freehand by clicking and dragging. But I'm going to show you the clicking and dragging method because it's going to be used a lot whilst you're working anyway. So let's say then that we want to move this, and we were on our selection tool. We have our move, rotate, and scale tools. So if I just click through them, I'll show you what the UI comes up with. So we click on move, and it comes up with this. So we've got 3 arrows. We have one pointing up, one pointing to the right, and then one pointing towards us. So this is our y-axis, our x-axis, and our z-axis. And so the idea is we can just hover over them. You see they change color when we hover, and then click on them, and then just move the mouse, and it will move only in that axis. It's not going to move it in any complex way. It's not going to be diagonal. It's going to be an exact movement on the x-axis, so long as when I was doing it, I was only touching the x-axis. If I undo that quickly, I could do that with the y-axis, and I can move it up, and I'll undo that. And I can do it with the z-axis and move it forward. One thing to bear in mind with this is that you have the option to click in the middle here, and you see we have this box becomes available to us. I can actually click and drag with that. And this is basically controlling the X, Y, and Z all at the same time. And it's quite hard to get your head around, because the way it's actually deciding how we move is based on the view that we're currently in. And so obviously we're in a perspective view. So if I orbit round, we can see that, you know, I've moved it to the side, but actually I've slightly moved it in the z-axis as well. And I've also slightly moved it in the y-axis, and we're actually higher. So there's reasons to use it, but it tends to be a little bit sloppier, and it's a bit harder to keep track of everything you're doing. So for now, we'll kind of work with moving one axis at a time, and do it the kind of slow, methodical way. So again, undoing that, let's just get on with what we were doing. We'll type in here -4 and just move our second object there. So this is now where we're going to play with the scaling. So if we now change our scale to -1 in the x-axis, if we think of the symmetry or the asymmetry that we have in our x-axis, that we have it kind of pointing this way, if we go to -1, it should flip us round so that we have a mirrored object. So if I type -1 and hit enter, we now have that exact object with all of its irregularities that I've created, you know, within, you know, the size of this square versus this square, or rather this cube versus this cube. But it's perfectly mirrored, and it's also perfectly in line with this other object, and we haven't moved it in either the y or the z axis. We've only moved it across in the x-axis. So if we wanted to kind of bunch these up together, we could actually now say, well, instead of it being -4, let's go to -3 and then -2. And because everything's kind of worked out mathematically, actually at -1, because we're moving it literally just off from each other, we end up with this perfect join in the center where they're actually mathematically going to line up. And so that's the whole point of a primitive, is that before you start really mucking around with a primitive, it's able to be mathematically positioned and augmented so that it can line up and everything kind of works. Once you start to deform it in, you know, more interesting ways, then you start to run into issues where the program will no longer be able to kind of do that for you. So let's delete these and we'll start with some primitives again. So that was the square, and what I'm now going to do is I'm going to make a sphere, and I'm going to move this over here. I'm going to make a cube, and I'm going to make a cylinder, and I'll make a cone. We'll make a plane. So a plane is basically like a 2D form in 3D space. So it's not got an actual mass to it. It is just like one part of a cube, one side of a cube, but it's something that we can use, and we can wrap them around things and cut holes out of them and all sorts of interesting stuff. We'll then have a torus. So a torus is a Homer Simpson style donut. We'll have a pyramid, and we will have what do they actually call this? They call it a tube? Polygon pipe, that's what they call it. But so these are the primitives that we can play with. And the idea is that you can start to use these, and you can start to augment them in order to create more complex forms. And once we have the base there, we can then kind of weld them together and create more interesting shapes. So similar to how an artist might sketch out the basic 3D blocks of something before trying to put any details on, we can kind of do all of that in 3D as well. So just to talk about what's happening here, because some of these look very different to the others. So if we look at the sphere, we can see loads and loads and loads of green lines over it because it's subdividing this shape a lot for us already. The polygon pipe's doing pretty much the same thing as that, as is the cylinder, as is the cone, as is the plane and the torus, but the pyramid and the cube are not. So why is that? Well, the reason is that for things to appear smooth in 3D, you need a little bit of extra information to kind of describe how a curve happens. So we need all of this information, you know, if we look at this kind of the lines dissecting it going upwards, we need enough of those to give us a smooth rounded shape, and we also need it on the other axis on here in order to give us the sense that this is a sphere. Whereas a cube is effectively made up of 6 squares, and the squares can be as simply put together as just 4 points. You know, and if these 4 points meet, you know, these 4 points and these 4 points, eventually we have a cube. So actually a cube can be very basic. And the pyramid is pretty much the same, other than we've got 4 triangles that meet on one square. So they don't actually need to be subdivided as standard. So it's something that we can then add into if we want to add details into them so that we can deform them. But we can also remove detail from some of these other shapes. So I'm going to show you how to do that. So if I select our cube, inside of my channel box, if I open that back up, we've got obviously our translate tools because we've moved them all slightly out of the way so we can have them all lined up. But if I now go down to the bottom, we have this inputs. So the inputs is what's being used mathematically to create this shape. So it's the process being called up by the program in order to understand the geometry of the shape. So if I click it, we have loads of options about this cube. So we have the width, the height, and the depth, all set to 1 at the moment. So this would work, if I changed any of these, this would work very similarly to how the scale works, and that if I change this to 0.5 in one direction, it's going to make that cube smaller in that direction. Just in the same way it works with scale, it's just another place where effectively these controls can change the size of our shape or size of our form. But importantly, this happens before, so the inputs happens before the actual final cube. So this is our control of the final cube. This is the inputs that create that cube. So we can either make the changes here or we can make the changes afterwards. It's really up to us. And importantly, actually, if I put this to 0.5, you'll see that actually our scaling stays at 1. Now, we won't get into why that's important, but there are some times where you need all of your scales of your general objects to reach a certain size so that all the mathematics kind of works together. And so if you need them to be different shapes, then by working on the inputs, actually that kind of helps because you can change the input size before changing the scaling, and then anything that requires processing of like multiple objects scaling will all work uniformly without it being all wonky. So put that back to 1. We won't look at height and depth, it's the exact same. Subdivisions then, this is what's happening with the rest of these shapes. At the moment we have one subdivision for our cube in each of the axes, but if I were to change that to, let's say, 4, 4 and 4, you can now see that we've cut this cube into multiple sections. Now, until we actually do anything to this cube, nothing really has been gained by doing this. It's still just as flat on the top and each side, and we don't actually have any more detail. We are, however, asking the computer to process more points on the cube that could be changed. So as you get to much higher levels of subdivision, this could actually start to slow the program down even when it's not doing anything. But for right now, at this amount, it's really going to be a negligible change. The important factor here, though, is if I just move some of these over out of the way, and I will start another cube. Oh, you'll also notice actually that so objects can intersect each other. They don't like hit and collide and then can't go any further. They will just overlap each other. Ideally, you don't want that to happen in your final work, but that's just something to bear in mind about the program. So if we compare this cube to this cube and we start trying to play around with this, we'll see what the differences are. So at the moment we're in object mode. So if you right click and hold right click on the shape, on the form, you'll get some options as to what type of things we want to control. So at the moment we're in object mode, but we could control a face, or we can control an edge, or we can control a vertex. So a face would be one of these, or on this cube, a face would be one of these smaller ones. A edge on this cube would be this line here, and on a smaller one, a edge will be one of these sections here. And then we have our vertices, our vertex. So a vertex is where the faces and edges all meet together. So on this cube we have them in the corners. On this cube you can see that we have them all over the place. So if we were to try and select one of these instead of selecting the object, we can now move this separately to that object. So the object, the rest of the vertices stay where they are, but we can move that one vertices and deform the shape. And so if we've done that now with this one here, if we try and do something similar, but we'll do it on this side so they don't intersect each other and we can see a bit better. So if I now move this one, well, because we've created so many more subdivisions, where we're pulling from is a much smaller area. So actually what we end up with here is more detail. You know, we have this straight edge that then moves to this spike at the edge of the cube. Whereas on this one, we just have a spike coming from a general mass. And the downside here is if we wanted this spike to then, you know, be on each side, well, we'd actually just end up kind of making this square again, because we're just going to end up pulling them in the same amount of distance, and eventually it will just become a square. So that's the reason why you have subdivisions. You have subdivisions so that you can keep certain parts of the mesh controlled in one way, and you can then deform them in another. So the next thing to look at then is cutting down subdivisions and kind of what can you get away with. So I'm going to move this sphere just out of the way, and I'm going to now go into the inputs of this sphere, and I'm going to make some changes. So we can make the radius changes, is basically going to change the scale of our sphere. But then we have our subdivisions on each axis. So we have our subdivisions on our height and our subdivisions on our circumference, I guess. So if we now change this, we're at 20 at the moment. So if we were to change this down to 8 and 8, you'll see that this still kind of describes a sphere quite well. You know, there's no real issues with that being a sphere, but it's certainly a blocky sphere. It's not something that is particularly rounded, but you can look at it and say, well, I get the idea that that's what that's trying to be. Now the question is, well, how many polygons do you need, and how much subdivision is suitable for whatever you're doing? And the answer is it's whatever the project requires. So if it's a project that requires you to be right up close to it when you're showing it to the audience, whoever that is, if it's a video game, if it's a film, or if it's any other kind of 3D asset, if you're going to show it to the audience at absolute clarity, where it's taking up the whole of the view, generally speaking, you want these to be high fidelity, which means that there is a lot of detail to create these objects. So you're going to have multiple subdivisions. You're going to have it, really smooth as standard. If, however, you're going to see it and it's going to be, this far away and it's just a background item, well, that might even be enough. I mean, it's a little bit blocky from back here, but it's probably not the worst. So the next thing we then need to look at is smoothing, because if we go back in time to what technology could do 15, 20 years ago, you couldn't have computers, tablets, or phones and stuff like that have the processing power in order to view these objects with a smoothing algorithm on them without having major lag and performance issues. But technology's come a long way, and basically any device that you can kind of get now will be able to do that no problem. So actually we can get away with saying our base mesh is low like this, but we view it in a smoothing mode. So at the moment we don't have any smoothing turned on, and you have on the keyboard buttons 1, 2 and 3 will change between smoothing modes. So 1 is no smoothing, and you see at the bottom it comes up and telling me how many divisions it's doing for the smoothing mode. On 2 it's going to add the smoothing, but the UI will stay the same, and it will give me I can still see all of my original subdivisions here. It's not going to remove those for me, so I could actually edit this and see where the original subdivisions were. And then 3 is going to give us our final smoothing, but it's going to remove those original subdivisions from the UI, so that we're just seeing the final output. Now that's definitely smooth enough to call a circle. So you would probably argue that in terms of polys, 20 subdivisions on the original sphere is a bit overkill. So it's something to bear in mind that, although the program might think that you're going to want 20 subdivisions when you start up a sphere, you're probably not. You're actually probably going to want to start smaller. It's also important that we can, so long as we haven't made any major changes to the sphere, we can actually go in and we can change this back. So we could say, actually, 8 wasn't enough, so let's go to 12 and find a middle ground. And that's something that we can then choose to do at a later point. So I'm pressing 1 again to go back to our unsmoothed version. So interestingly then, let's say that we make another cube. What happens if you smooth a cube that doesn't have any subdivisions? Well, if you smooth this cube, it's going to turn into a ball, which is odd, because it's not a cube in any way, shape or form anymore. So why is this happening? Well, if I select it, you can kind of see what's happened to the square shapes. They're sort of square, but they've almost formed like how football patches are put together to create a football. So why has this happened? Well, basically, if I go back to my unsmoothed version, basically when you turn on smoothing, what it's trying to do is it's saying, well, the distance between one point to the next point in the sequence needs to be smoothed in some way. And when you've only got a square that's a cube that's made up of planes without any subdivision, all it can do is smooth between the absolute extents, which then creates this ball. Whereas if we create or we just use the same one, if I go into inputs and let's say I give it, in fact, let's duplicate this and we'll put them all side by side. So we'll duplicate that and we'll move it over. We'll duplicate that and we'll move it over. And we'll duplicate that and we'll move it over. So we'll start with this one. This one we're not going to have any subdivisions. This one we will add 2 subdivisions to it. It's not going to allow. Right, okay. It's not going to allow me to create them from that because of the where they're all coming from the same object. So I'm going to need to create new ones. Bear with me. So that's a third one, and then we'll drag this 4th one on. So just very quickly then, so Maya has a system where it understands the history that how an object was created, and so previously it was seeing those 3 cubes being created from this master cube. And so then the kind of issue that it would have had is if I was changing the input on this one, it would have changed the inputs on all of them, and basically there's ways to break that, but it's certainly not what we're going to be doing in this session. So it's just easier to make them their own separate cubes with their own separate geometry. So the first one then, we're going to have inputs as 1. We're not going to subdivide it. The second one, inputs, we're going to go subdivisions of 2, 2, and 2. This one, subdivisions of 3, 3, and 3. And then this one, we will go 4, 4, 4, and 4. So as we go through them, you can see that we've got more and more subdivisions. And obviously we could continue on for as long as we want to. So if we smooth the first one, we get a ball. If we smooth the second one, we get a kind of a really smoothed over cube. It's the sort of thing that you wouldn't mind giving to a toddler because they're probably not going to cut themselves on it. And again, the same sort of thing then happens with the next one, but it's closer to being a kind of cube, and you can actually see the bevel that happens on the edge is a bit harsher there. And then obviously even more so when we come to the 4th one. So that's because we've added enough subdivision data in there in order for it to not smooth it over into an entire ball. And if you were doing it in this method, you would probably say that actually I might need to get up to, let's say, if we wanted it to basically be cube shaped, but with an ever so slight edge to it, so it's not, a perfect razor edge on the end, you're probably going to want to subdivide this to something like, maybe 12. So if we were to put this as 12, 12, and 12, that's going to give us that. If we then if we then smooth that, that's going to then give us this kind of like, well, it's a cube, but it's kind of it's a realistic cube that you might actually see things be made out of, because generally in the real world nothing's made with edges that form an absolute razor edge. There's always some kind of smoothing between them. But that's a really inefficient way just to get that edge to be how we want it to be. So if we know that we're not going to do anything to the center of any of these, all we actually need to do is we just need to add subdivisions where we want them to be them, rather than just saying subdivide it by 12 times in each direction. So if I make myself a final cube, bring that here. What we're now going to do is we're going to subdivide this by adding in an edge loop. So to show you what an edge loop is, if we take, we'll take this one for example. If I go into my edges, and you see obviously this is an edge. If I double click, this will highlight the edge loop. So an edge loop is a loop that goes all the way around and it meets at the other end. And so we have edge loops going across this way, and we have edge loops going across this way. We also have edge loops going across this way. So what I want to do is I basically want to insert an edge loop on our blank on our blank cube, so that we create this kind of harder edge without having to have all of this information on each of the sides, because it really is inefficient. So if I go into edge mode on here, you'll see if I double click on these, it's not going to give me an edge loop because they don't form full loops. They kind of close themselves off because there's not enough data there. So I can create more by adding in a edge loop to this mesh. And the way I'll go about doing that, if you go into Mesh Tools, you'll have Insert Edge Loop. And if we select that, you'll see it comes up in my toolbar. This is the tool I currently have on. And we had a thing that came up here that said Drag on Edges. So if I do that again, if I move over here, you'll see it says click to drag on edges. So the idea is that we need to click on an edge that already exists, and we click and hold, and you see we get this green line, and I can move left and right. I'm still holding down the mouse button. But as I'm kind of moving this is indicating where this edge loop will take place. So what I can then do is I can say, well, I want this edge loop to go almost right up to the edge here of our existing one, and place that in. And I want to do the same here. And then I'll do the same on the front at the top here. And the same at the front on the bottom. And then I'll do the same at the top at the front. And the same at the back at the front. So we've added in the 6 loops that we'll need, and so obviously because they're loops, they wrap around each other. So actually, you only need to do that the 6 times, and it will then have done the rest of the sides because of the way they wrap around. Now, obviously, you can zoom in and you can get these done perfectly. As you can see, actually, this edge loop here is much smaller than the others. So if I want to, I can go in and change it. So if I go into my selection tool, and I've got edges selected, I can double click, and now I'm on my edge loop, and I can move the edge loop as a whole. So I can go into my move tool, which obviously is in here. As a keyboard shortcut, you can press W to get to the move tool. The rotation, if I click on that one and hover over that, is E, and the scale is R. It's a bit of an odd one, but basically W, E, and R, which are all next to each other on a QWERTY keyboard, you can use to scale, rotate, and move your objects. The reason why it's most confusing is that scale is R and rotate is E, when you would have thought they just would have made rotate R, because then at least one of them is the kind of the letter that it begins with, but they didn't, and that's 3D. So anyway, so we can move that edge loop to kind of make that one match. And if we kind of have a look at this one, let's see how we come across here. So this one, this one I've made our edge loop by the look of it. Is that? Oh no, it's okay. It's just the lighting where it's so close to another box. I thought I'd put the edge loop so close that it flipped our image around a bit. But this side looks okay. The bottom and the top, okay, yeah, it should be fine now. So anyway, we've now made our own sections here. So now if I go into object mode and I smooth this, we then have a nice, slightly rounded cube that doesn't use anywhere near the same amount of data to create than that one does. And actually you can see the bevel that I've got on here is actually a lot sharper than even this one. So probably to get the same result on that one, I would have to move this to maybe something like, let's say 30. And 30. There we go, and that's now actually giving us a kind of realistic example of what this looks like to this one. But this is taking a lot of system resource in order to populate, as opposed to this, which is about as basic as you can get. So that's the idea of using either the mathematical way of having a primitive be subdivided within the system processes, or the way of manually putting in edge loops where they need to be used in order to control the way that smoothing works on the program. So that's a very quick overview on primitives. In the next video, we're going to start putting this into practice, and we'll be creating a Lego minifigure using these techniques. Thank you very much.